So, good evening, guys. Welcome back to the electric charges and fields, the second video, that is which is based on the Coulomb's law. Okay. So, in the previous video, if you remember, we have discussed regarding the what is meant by a charge. Okay. What are the different types of charge and as well as different properties of charge. Okay. So, the next one is regarding the Coulomb's law, that is which is very important concept in your class 12 syllabus of NCERT or whichever it is. Okay, so in this, okay, so this Coulomb's law, it is actually based on, if you remember, we have discussed it regarding the properties of charges as like charges, they repel each other. Okay, like charges in the sense, positive and positive, or it can also be negative and negative charges. These are called as like charges. And for example, if you take it as a positive charge and a negative charge, that is said to be unlike charges. What happens to unlike charges, my dear? They will attract each other. Okay, so this particular attraction or that repulsion, whatever it is there between the charges, okay, how strong is that repulsion, or how strong is that, or how weak is that attraction, okay, or how much force will be acting between the charges, that will be explained in the Coulomb's law. Okay, so look at this. Let us consider in this there are 2-point charges. 2-point charges, that is, one is a q1. Okay, so in the space they are actually located at what position vector, my dear? R1 vector. And the position of the second charge, it is, what is its position from the origin? It is at R2 vector. Okay, so regarding this R1 vector and R2 vector, let us discuss it again. But before that, let us assume that these both charges, they are separated at what distance from each other, my dear? They are separated at a distance of R from each other. Okay, they are separated at a distance of R from each other. So here what happens is, suppose if they are like charges means, I said that they should be either positive or they have to be negative. Okay, so this charges, they will repel each other. Okay, that repulsion or that attraction, we call it as electrostatic force. That force of attraction or repulsion between the charges, we call it as electrostatic force. Okay, so now just look at this carefully. One is q1 and other one is q2. Okay, these two charges, they are separated at what distance from each other? They are separated at a distance of r from each other. Okay, so now look at this. Here comes the Coulomb's law statement, that is now between these two charges there will be a force of interaction between them, right? That one we are calling it as which force there? It is called as electrostatic force. It is called as electrostatic force. What is the magnitude of that electrostatic force? It is directly proportional to product of charges. Okay, product of charges. Second one is inversely proportional to square of the distance. That means Fe, that is that electrostatic force, is directly proportional to Q1 multiplied with Q2. Okay, that means if you multiply the two charges, okay, you will be getting some value, right? Depending on that value, we can tell electrostatic force is large or small. For example, if that product is like, if that product is like, there are two charges. In one case it is 1 coulomb and another one is 3 coulomb. Okay, in the next case there is like 2 coulomb and another one is of 4 coulomb. The product of these two charges is how much? It will be 3 into 1 or 1 into 3. It is how much? 3. And the product of these two charges, it is how much? 2 into 4, 8. Okay, which one is greater, 3 or 8? Okay, generally 8 is greater, right? Okay, so between these two there is a possibility of having higher force. That one we call it as electrostatic force is directly proportional to product of the charges, and second one is it is inversely proportional to square of the distance. What is the distance between the 2 point charges? I said it is r. So Fe is inversely proportional to r square. By combining these both, what did you get there? Electrostatic force is directly proportional to Q1 Q2 by r square. I am telling you the statement of this Coulomb's law. Listen to this carefully. That is, the electrostatic force of attraction or repulsion is, first one, directly proportional to product of charges. And second one is it is also inversely proportional to square of the distance between them. Okay, and what did we consider? Don't write between them like this in the exam. Okay, it is between. Okay, right. Sorry, yeah, once again, the electrostatic force of attraction or repulsion between 2 point charges is directly proportional to product of the charges, and it is inversely proportional to square of the distance between them. Okay, so here if you observe carefully, now to remove this proportionality, okay, to remove this proportionality, we are equating it with a constant. And what is that constant, my dear? It is equal to how much? 1 by 4 pi epsilon naught. It is read as epsilon naught. Okay, epsilon naught. Okay, once again, Fe is equal to 1 by 4 pi epsilon naught. Already we have seen Q1 means the first charge, Q2 is the second charge, their product. That means we are multiplying them, and it is inversely proportional to r square. Is that okay? Which means that, for example, here inversely proportional to r square means if the distance is increasing, force between them will decrease. Okay, suppose if the distance between the charges is increasing, the electrostatic force of attraction or repulsion between them also will be decreasing. Okay, so what is meant by this epsilon naught? You said something in Greek language, sir. What is meant by that epsilon naught? Okay, it is called as permittivity of free space. Permittivity of free space means, for example, if there are two charges Q1 and Q2, if these charges, no, that force we said that it depends on product and it is inversely proportional to square of the distance. This force not only depends on these two, it also depends on in which medium these are present. Okay, for example, when they are present in free space, that force will be maximum. Okay, so what is that epsilon given there? Epsilon naught, that is permittivity means it is a property of that medium between the two charges. Okay, that means it is the effectiveness of that medium to allow that force between the two charges. You can remember it that way. Okay, how effectively a medium will allow that forces, allow that charges to attract or repel each other. That one we call it as permittivity of that particular medium. So here we are considering that those charges are in vacuum. When they are in vacuum, that permittivity of vacuum we have to take. And what is that? Epsilon naught value is 8.85 into 10 power minus 12 Coulomb square per Newton meter square. Okay. Remember this. Regarding this, we will discuss once again in the next upcoming videos. Okay. So for example, right now for this, you can remember this value. Okay. So this value of 1 by 4 pi epsilon naught, no, it is a constant value, and you can remember it as 1 by 4 pi epsilon naught value is 9 into 10 power 9 Newton per Newton meter square per Coulomb square. Okay. What is its value of 1 by 4 pi epsilon naught? It is equal to 9 into 10 power 9. After substituting this value in this particular equation, you will be getting it. Okay. Right. Next. So this particular Coulomb's law, okay, it is actually based on forces. Forces are vector in nature. Okay, they are not scalars. They will be having some direction also. So due to that, we say that it is a vector form. Okay. So that is the reason initially that Q1 and Q2, I have taken their position vectors as R1 vector and as well as R2 vector. Then according to vectors, the distance between these two charges can be taken as R2 vector minus R1 vector. Okay. So now before we go into this vector form, we need to know few points about this Coulomb's law. Okay. This Coulomb's law, it is based on Newton's third law. That is, here I said that there is a force acting between two charges, right? One is Q1 and other one is Q2. So here what happens? The force of repulsion between them, it is not only by one charge. It is a mutual between them. That is, Q2 will repel this with a force of F12 and Q1 will repel this with a force of F21. Okay. These both are equal and they are opposite in direction. Okay. Just like an action-reaction pair, this Coulomb's law, it also obeys Newton's third law. That means what is the net force acting here? F12 is equal to F21, which means F12 means force on 1 due to 2. Is that okay? Right. So this vector form, it is given by, and also these forces, they always act along the line joining the charges. For example, if you take, there are two charges, one is Q1 is here and another one is Q2 here. Is that okay? Then Q2 will repel this along the same line where those both are joined. Okay. Q1 also will repel the Q2 along that same line. Okay. So this force of attraction or repulsion will take place along the same line. Is that okay? Along the line joining the two charges. Okay. And what is that vector form, my dear? You can remember this formula. That is simple. Just as we wrote in case of the first one, that is electrostatic force. F is equal to 1 by 4 pi epsilon naught Q1 Q2 by, instead of R square only, what is that R actually? R2 vector minus R1 vector. Its magnitude we have to take, that is modulus of R2 minus R1 whole square. Okay. And as it is in vector form, that too along this particular direction, we have to take the unit vector along the same direction. So what is that F12? It is equal to 1 by 4 pi epsilon naught Q1 Q2 by modulus of R2 vector minus R1 vector whole square into R2 minus R1 whole cap. This cap represents, it is a unit vector. Okay. So this is about Coulomb's law. This is about Coulomb's law. And what is that Coulomb's law, my dear? It is the electrostatic force of attraction or repulsion between the two charges. It is 2 point charges. It is directly proportional to product of the charges and it is inversely proportional to square of the distance between them. And what is the formula? Fe is equal to 1 by 4 pi epsilon naught q1 q2 by r square, where epsilon naught is permittivity of free space. What is that permittivity value? 8.85 into 10 power minus 12 Coulomb square per Newton meter square. What is the value of that 1 by 4 pi epsilon naught? It is equal to 9 into 10 to the power of 9 Newton meter square per Coulomb square. In vector form, okay, this particular Coulomb's law, it obeys Newton's third law. That means there is an action and as well as reaction in this particular Newton's third law and in this Coulomb's law. So F12 and F21 both are equal and opposite, okay, and the ratio of their forces will be equal to 1:1. That is, force applied by 1 on 2 and force applied by 2 on 1. It will be in which ratio? 1:1. Okay, next. So that's regarding the Coulomb's law, and this numerical part you will be getting it in the next class. Thank you.